Alpha Centauri, our closest star system, is apparently sending objects in our direction, microparticles that are constantly entering our atmosphere without us even noticing. Imagine that pebbles from the Alpha Centauri system are lying undiscovered in our stream beds, or that a harmless-looking stone in a garden is, in fact, an extraterrestrial visitor. Scientists have now published an astonishing study for the first time about these interstellar visitors and their possible effects on our world. The latest research suggests that material from the Alpha Centauri system has already reached our solar system. This star system, located just over 4 light-years away, consists of 3 stars, Alpha Centauri A and B, which form a binary pair, and Proxima Centauri, a dim red dwarf. Not only is Alpha Centauri our closest stellar neighbor, but it is also moving toward us at 22 kilometers per second, or roughly 79,000 kilometers per hour. Researchers suspect that these movements and interactions between the star systems are facilitating the transfer of material between the Alpha Centauri system and our own. Advanced research methods now allow scientists to analyze the exchange of material between star systems. The newly published study estimates that substantial amounts of material from Alpha Centauri reach our solar system, particularly accumulating in the Oort Cloud, a vast and mysterious region at the solar system's edge. Traditionally, the Oort Cloud has been thought to belong exclusively to our solar system, but researchers now theorize that it may have formed through material exchange with Alpha Centauri. The Oort Cloud contains a variety of objects, from tiny dust grains and sand-sized particles to objects over 100 meters in diameter. Observing and studying these distant objects is extremely challenging due to their distance from the Sun and their vast dispersion. Astronomers believe the Oort Cloud serves as a protective buffer, capturing interstellar objects before they can enter the inner solar system, thereby reducing the potential dangers posed by free-floating space debris. Larger interstellar objects, such as Oumuamua and Comet Borisov, have already drawn significant attention in recent years, as they are believed to be the first interstellar visitors detected in our solar system. In reality, these may just be the first we have noticed, as researchers suspect that countless smaller interstellar objects enter the solar system every year without being detected. The study indicates that some material from Alpha Centauri is likely reaching our solar system continuously, with some objects taking up to 10 million years to travel the distance due to elliptical orbits, deflections, and the proper motion of the star systems within the galaxy. To survive such a long journey, these particles must be larger than about 10 micrometers. Researchers estimate that approximately 10 Alpha Centauri particles currently enter Earth's atmosphere as visible meteors. Meteors, which are smaller rock fragments, typically burn up upon entry or fall to Earth as tiny stones. The notion that rocks originating from Alpha Centauri may be present on Earth after traveling through space for millions of years is fascinating. If such meteorites could be definitively identified, they would offer unparalleled insights into the composition of another star system. Scientists remain uncertain about whether foreign rock and unknown minerals could have any significant impact on Earth's ecosystems. However, it is almost certain that these interstellar rocks have not been contaminated during their long journey and are unlikely to be dangerously radioactive. Incredibly, simulations suggest that over the past 110 million years, around 1,090,000 particles have been ejected from Alpha Centauri. These particles were ejected in random directions and at varying speeds, with only about 0.03% of them coming close to our solar system. These simulations help scientists understand how interstellar material enters the solar system and its potential effects. The research suggests that interstellar material from Alpha Centauri is already present in our solar system, primarily in the form of small stones, pebbles, and fist-sized lumps of rock. While the chances of larger objects reaching the inner solar system are low, researchers have simulated their possible trajectories to study the dynamics of interstellar material transfer. They aim to understand whether the composition of other star systems has any influence on our own. The interstellar visitor Oumuamua, which passed through our solar system in 2017, remains one of the most mysterious astronomical discoveries. Officially designated 1I/2017 U1, it was the first confirmed interstellar object to be detected within our solar system. Discovered by the Pan-STARRS telescope in Hawaii on October 19, 2017, Oumuamua exhibited an unusual cigar-like shape, measuring approximately 800 meters in length and 80 meters in diameter. It moved through the solar system at a staggering speed of about 87.3 kilometers per second on a hyperbolic trajectory, indicating its interstellar origin. What made Oumuamua truly remarkable was that it was only detected after it had already passed close to Earth. Unlike known comets and asteroids, Oumuamua lacked a visible coma or tail but exhibited unexpected acceleration that could not be fully explained by gravity alone. Some scientists suggested that outgassing similar to that of comets could be responsible, while others speculated that it might even be an artificial object, possibly a probe from an extraterrestrial civilization. To this day, Oumuamua remains one of astronomy's greatest unsolved mysteries. The second confirmed interstellar object, Comet 2I/Borisov, was discovered on August 30, 2019, by Russian amateur astronomer Gennady Borisov. Unlike Oumuamua, Borisov behaved like a typical comet, displaying a distinct coma and a tail of gas and dust. Its spectral analysis revealed an unusually high concentration of carbon monoxide, suggesting that it originated from a colder star system. Borisov's estimated diameter was between 0.4 and 1 kilometer, making it relatively small compared to other known comets. It raced toward the Sun at a speed of approximately 32 kilometers per second, reaching perihelion on December 8, 2019. Before leaving the solar system, Borisov split into two large fragments, as observed by the Hubble Space Telescope. Such disintegration is not uncommon among comets, especially those that venture too close to the Sun. The comet Shoemaker-Levy 9, for example, was torn apart by Jupiter's gravitational field in 1994 before ultimately colliding with the gas giant. Borisov's trajectory confirmed its interstellar nature, yet its exact origin remains unknown. It may have originated from a nearby star system or may have been drifting through the galaxy for millions of years before being drawn in by the Sun's gravity. After passing through the solar system, Borisov continued on its journey toward the constellation Telescopium, never to return. Given that Alpha Centauri is our closest neighboring star system, some researchers have questioned whether an asteroid or comet from there could one day impact Earth. It is widely accepted that asteroids and comets are common throughout the universe, often serving as remnants from planetary formation or the aftermath of cosmic collisions. Some interstellar objects may be ejected from their home systems by gravitational interactions or collisions, setting them on trajectories through deep space. If Alpha Centauri possesses a cometary cloud similar to our own Oort Cloud, disturbances from passing stars or other gravitational interactions could send some of its objects hurtling into interstellar space. If one of these objects were to align with an orbit leading toward our solar system, it could theoretically approach Earth. However, interstellar asteroids and comets travel at extremely high speeds and follow direct paths, making a collision unlikely. Unlike our solar system's native asteroids and comets, which are influenced by planetary gravitational forces, interstellar objects move like arrows on straight trajectories rather than like pinballs bouncing between celestial bodies. The first two confirmed interstellar objects, Oumuamua and Borisov, moved at incredible speeds, exceeding 90,000 kilometers per hour. While such speeds may seem alarming, they actually reduce the chances of a direct collision with Earth. The probability of an Alpha Centauri asteroid or comet impacting Earth remains low, but researchers continue to explore these fascinating interstellar exchanges, as they could hold critical clues about our cosmic neighborhood. Alpha Centauri, our nearest star system, is apparently sending objects in our direction. These microparticles are constantly entering our atmosphere, but we just haven't noticed them yet. Can you imagine that pebbles from the Alpha Centauri system could be lying in our stream beds, or that a harmless-looking stone in the garden might actually be an extraterrestrial visitor? Scientists have now published an astonishing study for the first time about these interstellar visitors and their possible effects on our world. The latest research shows that material from the Alpha Centauri star system has already reached our solar system. At Space Lab, we bring the universe closer to you. Stay curious, keep exploring, and subscribe for more mind-blowing cosmic discoveries. The journey through the stars is just beginning.